So in the last lecture, we did an explanation of binary search tree. It's basically a binary tree where the left node is always smaller than the right node or the parent node, but the right node is always greater than the parent node. Everything on the right is greater than everything on the left, and if you need more explanation, you can check the last lecture. But in this lecture, we do an implementation of binary search tree by first creating a node tree class. This is how we create the nodes. So we create a constructor. We've done this a few times. This dot value equals to value, since value is an argument. This is determined by you. This dot left for now equals to null. This dot right for now equals to null. Now we create the class of binary search tree. So we create a constructor like any class which takes a root, and this dot root equals to null. Okay, now we give this binary search tree a method. The method of insert means to insert any node that we create from this binary search tree into the tree. So how do we give it? Well, we say const new node equals to new node tree, which takes the value. So now we have a node tree, node from the tree. Now if this dot root was equal to null, then this dot root equals to new node. Now the first thing is, if this root was null, then make the new node a root. Else, so if it wasn't null, first things first, let current node equals to this dot root. So if the root was not null, while true. So this is a condition. So this is a condition that if the root was not empty, then create a loop. If value was smaller than current node dot value. So this is node for now. If the value was smaller than node, if current node dot left, current node dot left equals to new node, then return this. Now at the end we have to do current node equals to current node dot left. So why did we do this? Well, we have the root, we create a loop, we say if the value is smaller than the value of the root, then if the root didn't have any left, make this node to its left. If it has, then skip it. Here we say current node is equal to current node dot left. So it goes until it finds null and it updates left if the value is smaller. Now, as we are done with the left, we do right. If current node dot right, so if we didn't have current node dot right, just like the left, current node dot right equals to new node, return this, then current node is equal to current node dot right. So we did the same as we did for the left. If we didn't have right, then make the node right, else go through until you find the right node. This is all binary search tree. We create a node. If there is no root, we make it a root. If there is root, we create a loop. We say if the value is greater than if the value is smaller than the root's value, then if the root didn't have left, make it left. Else go until you find the left of that value as null, that node as null. The same thing for the right. Now if we test it, we say maybe I should just bring something here so we don't spend much time writing. So we do BST is equal new binary search tree, then BST insert 10, and at the end of the day we log the thing, the binary search tree. And if we do like see the log, we see value of 10 with left of 2, right of 12, left of 2 has another value on the right but doesn't have a value on the left, but right has left and right of null. So this is how we do binary search tree. Thank you.